Section 12.8b is about simplifying complex fractions. A complex fraction is a fraction that has one or more fractions in the numerator and the denominator. Something like 8/3 divided by 7/5. That is a fraction in its numerator and its denominator, and we're going to learn to simplify that. It also works with letters. If you have a over b divided by c over d, you have to learn how to simplify that. And those are complex fractions. So here's an example of a complex fraction. We'll talk about how we can simplify it. What I would do is I'd turn this top into improper fractions first by making it 7/2 over 19/4, because it's a lot easier to deal with improper fractions than it is with the mixed numbers. Now, we've learned in the past that dividing is the same as multiplying by the reciprocal, and that's the key to solving this here. We make 7/2, and instead of dividing by 19/4, we're going to multiply by the reciprocal of 4 over 19. Now that we have multiplication, it's a lot easier. 2 will cancel with the 2 leaving a 1, with the 4 leaving a 2. No other canceling can be done, so I go straight across, get a 14 on the top, get a 19 on the bottom, and I'm done. Here's a complex fraction with letters. Let's see how that's going to be different. I'm going to take the a to the 5th b over the c squared, and instead of dividing it by that fraction, I'll multiply by the reciprocal of that fraction. So c to the 4th on top over a b to the 4th on the bottom. Now it's a lot easier to cancel. I have 2 c's here and 2 here, so I cancel 2 of them, leaving a c squared. One of the a's are gone, leaving an a to the 4th. One of the b's are gone here, leaving a b to the 3rd. So we'll have a to the 4th c squared all over b cubed. So here's an example that begins to incorporate both ideas of mixed fractions and complex fractions. Now I see this division of a plus 3, so I know that I'm going to multiply by the reciprocal at some point. But this numerator has to be taken care of. I have to take this a over 1 minus 15 over a minus 2, and I have to combine those. I got to get them into one term so that I can multiply by the reciprocal. So I'm going to look at that and say the LCD of that piece is a minus 2. So I'm going to multiply by a minus 2 over a minus 2. Then I'm going to distribute this a. So a squared minus 2a, and then I'll have minus 15, and all of that will be over the common denominator of a minus 2. That's simplifying a mixed fraction like we did in section 12.8a. Now all of that is now divided by a plus 3. So I can change that to be times 1 over a plus 3. So I simplify the mixed fraction on top, and then I multiply by the reciprocal of a plus 3. And now this is a problem that we've seen in the past. We can solve that. Take this trinomial and factor it using a diamond. 2 factors of negative 15 that add to be negative 2a minus 5a plus 3. Now I can factor or cancel the factors a plus 3, and looks like an a minus 5 on the top, an a minus 2 on the bottom. Nothing else cancels, so I'm done. Our last example here, you might want to pause the video, try it for yourself, and see how you do. I'll start with the b over 1, add that to 2 over b plus 3. We know the LCD in that case is b plus 3. So we multiply here by b plus 3 over b plus 3. So we'll distribute b squared plus 3b plus 2, and that's all over the common denominator of b plus 3. Here we have b minus 4 that we're dividing, so we multiply by the reciprocal, 1 over b minus 4. So using the diamond now, 2 factors of 2 that add to be 3 are b plus 2 and b plus 1. And multiply that by 1 over b minus 4. Now there's nothing that cancels, so all I can do is multiply all of those binomial factors by each other. And the denominator b plus 3 times b minus 4. You can't cancel any pieces of it, So that's going to be my final solution.